Greetings everyone, this is Giselle Bibobor, and in this video we will be proving geometrical statements. Our first problem. The given is line segment BD is congruent to line segment DC. Now, I want to apologize for not having the bar symbol above the line segment. Believe me, I did what I could to find it because I'm only using phone, so I was not able to find a symbol for line segment BD. Anyways, just take note that two letters is a line segment. The first given is line segment BD is congruent to line segment DC, and line segment BD is perpendicular to line segment AE. And lastly, line segment DC is perpendicular to line segment AF. Now, what we have to prove is that AG bisects angle A. Now we have to put the markings of the given and their consequences, and also of the statement that we have to prove. So, first given, markings on line segment BD, which is congruent to line segment DC. And also, line segment BD is perpendicular to line segment AE, and its consequence is that it will form 90 degrees right angles. Same with the last given, line segment DC is perpendicular to line segment AF, and it also gives us a right triangle on angle DCA. Now there is a marking on lines on angle BAD and angle CAD because these are the two angles that is on the vertex that are the vertices of angle A. Now before that, please pause the video and make a copy of the figure so that you can follow when I give the statements and reasons. So statement number 1, line segment BD is congruent to line segment DC. Reason given. Second statement, line segment BD is perpendicular to line segment AE. Reason again, given. And number 3, angle DBA is a right angle, which is the consequence of perpendiculars. And reason, yes, of course, perpendicular lines form right angles. And number 4, line segment DC is perpendicular to line segment AF, also given. Number 5, angle DCA is a right angle, because perpendicular lines again form right angles. Now, angle DBA is congruent to DCA because all right angles are equal. Number 7, line segment AD is congruent to line segment AD because of a reflexive property. And now we can conclude that triangle DBA is congruent to triangle DCA. Reason is number 1, 6, and 7, HL theorem. Number 9 is angle BAD is congruent to angle CAD. And the reason is CPCTC, corresponding parts of congruent triangles are congruent, or CACTC, corresponding angles of congruent triangles are congruent. Number 10, angle A is comprised of two angles, angle BAD and angle CAD. We add them, and the reason for this is partition postulate. The parts is equal to the whole. And number 11, of course, AG bisects angle A, and the reason for that is definition of angle bisector, QED. Now for the second statement that we have to prove, you're given Two right triangles are congruent if the hypotenuse and an acute angle of one are congruent to the corresponding parts of the other. We are in symbols. It is the given is triangle ADB and triangle CDB are right triangles. Line segment AB is congruent to line segment CB, and both are hypotenuse. And the congruent acute angles are angle ABD, which is congruent to angle CBD. We have to prove that triangle ADB is congruent to triangle CDB. Now we have to put the markings. Triangle ADB and triangle CDB are right triangles, which means each of them has one right angle. And the hypotenuse, we put the markings on the two hypotenuse, line segment AB and line segment CB. We also put markings on the acute angles, angle ABD and angle CBD. We have to prove that again, triangle ADB is congruent to triangle CDB. Statements and reasons. Our first statement is triangle ADB is a right triangle, which is given. Next, angle ADB is a right angle. Reason, a right triangle has one right angle. Number 3, triangle CDB is a right triangle. Given. Number 4, triangle CDB is a right triangle. And reason, a right triangle has one right angle. And number 5, angle ADB is congruent to angle CDB because all right angles are equal. And number 6, line segment AB is congruent to line segment CB because it's a given. And number 7, angle ABD is congruent to angle CBD because again it is given. And now number 8, lastly, triangle ADB is congruent to triangle CDB because of 5, 6, 7 SAA theorem. QED. Now for the third geometrical statement that we have to prove. The given is rectangle ABCD, and another given is EA is congruent to DF. We have to prove that BE is congruent to CF. We have to put the markings. It is rectangle ABCD, and as we know, a rectangle has 4 right angles. We have to put the markings on line segment EA and line segment DF because they are given to be congruent. And we also put markings on red markings on what we are going to prove. The line segment BE that is supposed to be, and that we have to prove that it is congruent to line segment CF. Now for the statements and reasons, number 1, rectangle ABCD is of course given. Number 2, angle CBA, angle CDA, angle BAD, and angles DCB are right angles. Reason, each angle of a rectangle is a right angle. Number 3, angle BAD is congruent to angle CDA because all right angles are equal. Number 4, angle BAE is congruent to CDF because supplements of congruent angles are congruent. Number 5, line segment EA is congruent to line segment DF because it's given. Number 6, line segment BA is congruent to line segment CD because opposite sides of a rectangle are equal. And number 7, we can now conclude that triangle BAE is congruent to triangle CDF for the reason of 4, 5, 6 SAS postulate. And lastly, we have now proven that line segment BE is congruent to line segment CF because of CP/CTC, corresponding parts of congruent triangles are congruent, and more specifically because of CS/C/C, which is corresponding sides of congruent triangles are congruent. QED. Now for our last geometrical statement to prove, we are given in right triangle ABC, measurement of angle C is 90 degrees. If Q, M, P are the midpoints of AC, AB, BC respectively, prove that QMPC is a rectangle. In other words, we are given right triangle ABC and a measurement of angle C is equal to 90 degrees. QMPC are midpoints of AC, AB, and BC respectively, and we have to prove that QMPC is a rectangle. Now to put the markings, we are given that angle C, the measurement of angle C is 90 degrees. As we can see, there's an indicator in the figure, and we put QMPC in the middle of their respective line segments. Q as a midpoint of AC, M midpoint of AB, P midpoint of BC. And we have to prove that QMPC is a rectangle. Now statements. Right triangle ABC given, measurement of angle C which is 90 degrees given, Q is the midpoint of AC given, M is the midpoint of AB given, and QM, line segment QM is parallel to line segment BC. Why? Because of the principle, if a line joins the midpoints of two sides of a triangle, then it is parallel to the third side. The line that joins the midpoints of two sides of a triangle is QM, line segment QM, and the third side here is line segment BC. And according to this principle, both the two lines are parallel. Number 6, D is the midpoint of BC given, and also line segment MP is parallel to line segment AC. For the same reason, in number 5, if a line joins the midpoints of two sides of a triangle, then it is parallel to the third side. Number 8, QMPC is a parallelogram. Why? Because of the definition of parallelogram. The definition says that opposite sides of a parallelogram are parallel. And because we are given opposite sides as shown in the figure, and we know that they are parallel, then QMPC must be a parallelogram. And number 9, parallelogram, QMPC is a rectangle, because if a parallelogram has one right angle, then it is a rectangle. QED. Now that is last of the geometrical statements that we will prove in this video. Thank you for watching. Goodbye!